Hello everyone, this is question 1 from these energy level questions that you've been looking at. The maths is actually really nice and easy, most of you doing it quite well. It's just that kind of picture of what's actually happening in the question. It's slightly more difficult. So what we've got is a certain energy level, minus 3.4 electron volts, and it's negative because it's trapped, so we can see it and see what we're doing with it, right? And we've got a photon of wavelength 656 nanometers being emitted. So what that means is we're dropping from a higher energy level into a lower one. And what we're trying to calculate is what is the energy of this particular energy level in joules. So let's go through step at a time and see what we can do. So the first job is we can work out the energy difference here. So we know that energy is equal to HF, but because they've given us a wavelength, let's go HC over lambda. We can put our values in. So apparent constant H 6.63 times 10 to the minus 34. We've got the speed of light, 3 times 10 to the 8 meters per second, and then our wavelength is 656 nanometers. So let's put that into meters times 10 to the 9. You can be clever and kind of do standard form, and it's 6.56 times 10 to the, and then I need to kind of think about what it is. If I just do it to 10 to the minus 9, the calculator to do the hard work for me. And if I stick numbers in, I'll get 3 times 10 to the minus 19 joules. So that's my difference in energy between here and here. Problem I've got is I've got an energy in electron volts and an energy in joules. So I've got a choice now. Do I put this into electron volts or do I put this into joules? Because I want my answer up here in joules, well, it kind of makes sense to start converting this. So my 3.4 electron volts will be 3.4 minus, let's not forget that, times 10 to the minus 19, sorry, I'll try that again, minus 3.4 times by charge an electron, 1.6 times 10 to the minus 19 joules. So that's going to give us minus 5.44 times 10 to the minus 19 joules. So I know that's 5.44 times 10 to the minus 19 joules, that energy level. I know my difference here is 3 times 10 to the minus 19 joules. And what I also know is going up the way, up here, is where 0 is going to be. So this number is going to be less negative. It's going to be closer to 0, whichever version of that kind of makes sense. So if I want to work out what my energy level is going to be, it's going to be my minus 5.44 times 10 to the minus 19 joules plus 3 times 10 to the minus 19. The only reason I picked plus there is because I know I want a less negative value. So again, put that to my calculator, I'll get minus 2.4 times 10 to the minus 19. The minus bit's really, really important. I know it doesn't ask for this in the question, and that's the right answer, that's on the mark sorted, but what you can do is if I convert that back into electron volts, it comes out to minus 1.5 electron volts. The reason I've done this is for hydrogen, it's the hydrogen spectrum, which is kind of a classic thing that we like to ask about. And if I just flip over to question 3 really quickly, right? Well, this is the same thing. Minus 3.4 is the energy level they gave us. B here, this transition, is our 656 nanometer transition. And then we've worked out this minus 1.5. So we've worked out exactly the same thing, so we know it works. But because it's a standard thing that always comes up, particularly that ground state of minus 13.6 electron volts, minus 13.6 electron volts, it's good to know the rules in our area. We can use that to help guide us. Well done.